All right. Hey, everyone. I'm excited to introduce our new coastal geologist from the Illinois State Geological Survey. I say new, but he has been with us since, I think, February or March, since the pandemic started. And he's been doing, in just a few months, he's been ramping up a lot of work in helping us understand shoreline change along Illinois and Lake Michigan. So I'm really happy to introduce Christopher Robin Matthews. He has over 10 years of experience as a postgraduate professional geologist, and before he joined us, he was with the Delaware State Geological Survey. So I'm really looking forward to his presentation, and he makes these amazing visuals. So take note of those. I think you all will really enjoy that.
Thank you, Vidya. Can everyone hear me? I think I'm unmuted.
No, we can hear you.
Okay, awesome.
Yes.
So the Illinois Coastal Management Program and the State Geological Survey have been involved in this collaborative effort to monitor shorelines at Illinois Beach State Park, where retreat has really accelerated during the current high water phase. And I'd like to showcase some of the insights derived from our mapping efforts, which may help inform a research approach to looking at beach shorelines in Chicago, which I think is sort of the topic of this, this webinar. Next slide, please. We can click once. Sorry, I've embedded all of these little things. So most of us are familiar with Illinois Beach State Park. It's situated in northernmost Lake County, and it's a very unique place ecologically. It houses around 1,000 plant and animal species, of which more than 60 are protected by the state. Click again. And so this makes shoreline erosion quite problematic. It threatens not only ecologically important wetland habitats, but it's also destroying park infrastructure that the tourism industry sort of relies on. Next slide, please. So we geologists always like looking at the past, and when looking at historic water level records for Lake Michigan, we can see that our current position is geologically, or I shouldn't say geologically, but historically not that unique. Lake levels have been this high before several times over the past century. The 1.8 meter rise from 2013 to present levels, click. It compares well in terms of magnitude to the 1964 to 74, click, or the 1926 to 1929 rise, click. And so we can look at rate comparisons if we click one more time, and we can see that the 1920s event happened much more rapidly. And so there have been more dramatic events in this sense. We're trying to figure out whether rates of rise are important for shoreline dynamics or if it's just the magnitude. Unfortunately, we don't really have much information on shoreline dynamics from the 1920s, but that's sort of where our monitoring efforts come in now. Perhaps what most distinguishes our current situation from other high stands is not that lake levels came up quickly from very low to very high conditions, but that this transition was preceded by a lengthy low stand period comparatively. We had about 15 years of low water levels to, I think, lull us into a false sense of security. Advance. So given its low elevation terrain, Illinois Beach State Park is particularly vulnerable to high lake level phases. It is part of the Zion Beach Ridge Plain, which is a geologically unique terrain that is characterized by ridges and swales and this sort of washboard type topography that we see here. And this terrain formed as a function of lake level changes, and very few areas are more than 1 to 2 meters above current lake levels. And unlike coastal bluffs, small changes here can really impact broad swaths of coastal terrain. And I've put together a graphic to illustrate this, and I should explain the map first. You can see the 1939 shoreline as sort of this black stippled line, and in white is the 2017 shoreline. To the right in the pink to yellowish colors, that would be water depth, And on the left-hand side of the shorelines, obviously, are the beach ridges, the terrain that's just above lake level. And A to A prime, which is shown in a profile graph to the right, that's an extraction of the terrain elevation. And so in blue, I'm showing where the 2019 lake levels stood and which areas of the coast here were inundated. Now, there wasn't much inland flooding at Illinois Beach State Park until about 2018 or so, when we reached near current levels. To make a point here that inland flooding can happen suddenly, if we click, what's going to happen is lake level is going to come up incrementally, and you'll see on the map and on the profile what happens to the terrain. And so this would be an additional meter of lake level rise and the amount of terrain inundated. Keep in mind, we've come up 1.5 meters from 2013 to 2019. So this shows that this whole terrain, you know, lake levels where they stand now, they're sort of at an elevation threshold of sorts. So if lake level came up any more, there would be very rapid changes in the coastal landscape here, just given the nature of the terrain. Next slide. So to study shoreline change, particularly when things are at their most dynamic as they currently are, we need to look landward, and we also need to look lakeward of the present day water lines, because the surrounding terrain changes seemingly on a storm by storm basis here at Illinois Beach State Park. To fully survey this dynamic interface of land and water, we rely on a variety of data acquisition methods. The terrestrial realm can be mapped by drone. We perform wading surveys in shallow water. We also make use of crewed vessels and drone boats in deeper water. And since all of these data are collected at the same time, we can stitch them together and provide complete terrain models of what we call the white ribbon, which is named because it's the area that's often not included in bathymetric and topographic maps. It's that area of change between where the terrestrial people map and the deeper water people do their maps. So to monitor this area well, we have to do multiple surveys a year, which is quite an endeavor, but it teaches us much about process and form and the fate of sands that are lost from the shoreline. And we have focused our attention on a handful of highly dynamic sites at Illinois Beach State Park. Next. So here's one of our sites. The aerial images to the left show what things looked like in 2012 and in 2018. And we can immediately see that the shoreline retreated. But what these images don't tell us is what other changes occurred. And this is really important to note. Click. So here's a map of corresponding elevation changes based on our surveying efforts. These are stitched together from those different methods I just mentioned. And shades of red reflect elevation losses over time, and blue colors reflect elevation gain over time. And the shoreline positions from 2012 and 2018 are superimposed. So now we can actually quantify what's been lost and contextualize the shoreline retreat a bit more. Drone-based mapping is very useful for capturing changes over the short term like this. If we click again, you'll see a photo of the same area in summer of 2019, and you'll notice a difference. This was following an emergency sand nourishment project to protect this road that was being threatened in 2018. If you click again, this is a location of images that I'll be showing in the next slide. So let's advance and take a look at how the road fared over the winter period. You can see not very well. This is a look down the axis of what would have been the road. And you can see different images here of the road bed that's being exposed and undercut. So a lot of change happened. If we advance to the next slide, we can take a look at this as captured in our data from our many surveys. The model to the left shows August 2018 to August 2019 changes in elevation. And you'll notice this area in blue. Well, that was the sand that was put in place to protect the road. Click. And now if we look at the same area, but this time modeled for October 2019 to July 2020, we see that the area that was in blue before is now in red. That indicates loss. And if we look further down the coast to the south, we notice some areas in blue behind the shoreline. That's where this material ended up. So a lot of it was overwashed. It migrated down the coast, but it didn't stay put for very long. And so having these sorts of data sets to provide us with sand volume estimates, we know that not all of the nourishment sand ended up as overwash. Some of it must have gone offshore because the budget doesn't quite match up. These sorts of data sets are really crucial to helping us understand what happens when lake levels are high. Next. So the take-home message is that we did not have a mapping approach like this the last time lake levels were high, which was in the 1980s. So we're learning a lot about the processes that are unfolding along places like Illinois Beach State Park during a very critical time in terms of lake level position. And hopefully we can put some of the observations from earlier lake level highs into a context, because we do have historic aerials that allow former shorelines to be mapped, going back to the 1930s. So these new process-based studies, I think, will over time reveal a lot about what past changes also occurred. If you're interested in learning more about our mapping procedures or generally what coastal changes have occurred at Illinois Beach State Park, please check out our story maps. Those are products that our research group has diligently put together right now while COVID has sort of kept us indoors. I should also mention the many folks that have been part of these activities of data collection, processing, et cetera. As Vidya mentioned, I just recently joined the crew, so these folks really deserve the credit for this awesome work. I'm probably forgetting some names here in this list, but a lot of time and effort has gone into studying the Illinois Beach State Park system, and the story maps showcase this quite well. Next slide. So just a few things to mention. The ISGS is also gathering other types of information, because knowing what coastal changes have occurred is only part of the equation for understanding shoreline dynamics. Our group has deployed buoys to collect wave and current information to integrate with our models of coastal change. And the key here is that these are close to the shore where all the action is, unlike most other lake buoys that are out in deeper water. And over time, this will hopefully allow us to better address what sorts of events, hydrologic events, meteorologic events, are associated with the coastal changes that we map. The ISGS also operates some weather stations. We have cameras installed at different places to provide imagery of coastal change as it happens. So this is what I showed today is just part of a much larger endeavor to better understand the coast. Next. We're also interested in mapping offshore sand distributions and have recently done some magnetic mapping from the air. The TEM method measures electrical properties of sediments and rocks, and this is very material specific and has allowed us to derive thickness estimates of different earth materials of the nearshore area. And the study has shown that there's a continuous sand blanket of several meters of thickness offshore at Illinois Beach State Park. And the map to the right, you can see that as the sort of green area. And elsewhere, there isn't all that much sand, unfortunately. Where present, it's relatively thin and discontinuous. So this has major implications for coastal evolution that we're starting to sort of unravel. Next slide, please. And we're also beginning to redirect some of our research efforts to Chicago's beaches, which have also been negatively impacted by high lake levels. This 1914 map on the left shows the locations of some of these beaches today in yellow. And particularly would like to help figure out how shoreline infrastructure and other site-specific variables such as beach orientation are maybe influencing their behavior. Some preliminary results based on existing elevation information from 2012 and 2017 reveal that beaches have responded very differently to the same lake level rise. Some beaches rotated, others disappeared entirely. Some changed relatively little. So we're kind of interested in knowing why. Why do we have these changes? Last slide. And I'll end with a look at Montrose Beach. If we click, it'll sort of go through a series of images that I yanked from Google Earth. And you can see all of the changes that have taken place. Oops, that was supposed to, oh well. And there's been a lot of change over time, I think, is the take home. And we're looking at into working with the Chicago Park District to install cameras at this beach and maybe other beaches to sort of help monitor or keep track of all of these changes that are happening to the shoreline and help us better understand what's going on from a process-based perspective. High lake levels are one part of the equation, but then there's winter ice and all of these other things that happen that are quite difficult to document. And so having cameras installed that can collect imagery continuously will really help with sort of understanding what's going on dynamically. And that is all I have.
All right, thank you for that presentation. We did get a couple of questions. First, Vidya shared the link to the story map that you had showed. And then one of the questions we had is, in your slides showing a cross-section through the park where you raise the water level to show flooding of the park. Sorry, it cuts off here. The A shows a high dune area where the shoreline, so that through the images show a rather flat shoreline. Can you explain what this higher area next to the water represents?
Well, that's part of the very dynamic white ribbon, as we call it. It's essentially the beach berm. It's higher in elevation than much of the terrain that's landward. And so when that very narrow, high elevation part is breached, sand can overwash and sort of find its way into the lower elevation marshy areas that are behind that. So that's the short explanation. If we go to that, that's the most dynamic part of the system because it's what's interfacing the lake, or it's interacting with the lake, and storms modify that. So the A prime part of the system is sort of the crucial part to understand, I think. And again, the overall elevation of the plain is such that where lake levels are right now, we're right at this threshold. If lake level came up another quarter meter or so, a lot of areas behind that A prime where it is today would be inundated, and that would sort of weaken the system as a whole. So it would make overwash probably more likely, and shoreline retreat more rapid.
Great, thank you. And then we did have a question or comment asked if we could post in the chat some resources for understanding impact of rising lake levels on developed land, such as homes and businesses. Vidya did post a link to an article, but I think some of this is also what's going to be discussed coming up here in the breakout sessions. So I think I got all of the questions.
Margaret raised her hand.
Oh, sorry. Go ahead.
Yeah, thanks. I figured I would just ask if you had done any research on beach morphology that is typical to saltwater coastlines and how that might differ to our lake coastlines. I was having a conversation recently with someone who studies saltwater coasts and the beaches there, and he made the comment that sediments that are blown around a lake system that carry more nutrients and allow for more plant life to grow actually change the permeability of the nearshore sediments, and therefore they don't react in line with saltwater beaches and the morphology that is typical and more widely studied in those locations. And I wondered if you had done any research to that in that field and found any difference in morphology between the Great Lakes and our saltwater systems?
That is really interesting. I have done quite a bit of work in saltwater systems, but most of that was further offshore or in estuaries. So, but in terms of beach processes, I can definitely see where vegetation characteristics here in the Great Lakes have much more of an influence on what's happening to the shoreline. If I'm thinking of the Outer Banks of North Carolina or other sorts of sandy beach systems and ocean settings, yes, the dunes are vegetated with grass and all of this good stuff, but here we have, cottonwood trees recruiting along shorelines and in doing so very, very rapidly. So I think vegetation takes a hold much more quickly here than it would on oceanic coastlines, and just given the absence of salt and that sort of hostile condition that keeps most plants sort of confined to the dunes. So just having observed what's going on at Illinois Beach State Park, there's definitely a very strong impact of the vegetation on erosional dynamics. I can say that much. Just the root mats, the wetland plants that are sort of anchoring things in place. And so when the shoreline recedes, it doesn't recede uniformly. It's highly variable, and that's due in part to what plants were sort of holding things in place and where trees were, and get all that woody debris littering the shoreline, which then influences what the waves do. So it's something that's very difficult to quantify.
Yeah.
But yes, the vegetation is important.
You had mentioned in one of your slides about the cyclic nature of the water levels and how they change, and that we had gone through a period of about 15 years of low water levels, which allowed, of course, the vegetation to extend lakeward. And those other two times that we had rapid change in or elevation or increase in water levels, we were not preceded with the low water level. So I wonder if in your research, part of that is looking at the influence of the vegetation and also the densification of the soils along the shoreline, and if that aids to a rapid retreat of the shoreline versus if it was more highly permeable, whether that retreat would be lessened.
I mean, it is something that we have been considering, looking at the vegetation characteristics. Of course, it would be difficult to compare what's going on now to what happened in the 80s, because in the 80s, well, the only data we really have are aerial photos, and we don't have this detail of what was going on with the shoreline and where overwash was occurring. So we'd have to base interpretations on imagery alone, which is a little more difficult. But it would be very interesting to compare the dynamics of what's happening now during the high lake level phase to what we think was happening during the 80s high lake level phase and earlier high lake level phases. But just, I don't know enough about the vegetation here to have an understanding of what happened in those 15 years that lake levels were low. How well established were the landforms that maybe are attributed to that period, and the vegetation that sort of occupied those landforms?
I'm going to have to step in here. This is really interesting conversation that's going on, but we do have to move along a bit. So thank you again for your presentation and all of the great questions. We didn't get around to all of them. So I think we have Robin's contact information, and you can either reach out to him or we can get